Hello class, and welcome to section 4.3, which is about elimination. By the end of today's lesson, you will be able to solve systems of equations using elimination, and you will be able to identify the best possible method for solving a system of equations. So to start, elimination is our final option for how we can solve a system of equations. The goal with elimination is to remove one of the variables by getting rid of it. So this means we're canceling it out from both equations by using opposites. The solutions to the system of equations are still ordered pairs. It is still us trying to find that point of intersection between our two lines. When we eliminate, again, our goal is to get rid of something. So if we start with this equation, 8x plus 3y is equal to 11, and our second equation is 8x plus 7y is equal to 7, our goal is to get rid of one of the variables. In order to get rid of one of the variables, we have to have the same quantity. So in this one, it's our x's. I've got 8 x's in the first and 8 x's in the second. To get rid of that, I'm going to subtract. 8 minus 8 gets me to 0 x's. If I added these equations together, 8 plus 8 would give me 16 x's. That doesn't make the variable go away. So we're going to subtract 8 minus 8 gives me 0 x's. 0 times x, that's gone. So our x's are gone. Now because we subtracted the x's, now we have to subtract the y's. So 3y minus 7y is going to give me negative 4y. Then we're going to subtract the answers. 11 minus 7, which is going to give me 4. So by subtracting these two equations, I've gotten rid of, in this case, the x variable. Now I can go ahead and keep solving for y, dividing by negative 4 on both sides, giving me an answer of y is equal to negative 1. We're only halfway done because we need to plug this back into y. It does not matter which equation you plug back into, as long as you plug into one of the equations. So I'm going to pick the first one, and I'm going to say 8x plus 3 times negative 1 is equal to 11. When I continue to solve that, I'm going to get 8x minus 3 is equal to 11. As I continue, adding 3 to both sides, so that's going to give me 8x is equal to 14. And I'm going to finish by dividing both sides of my equation by 8, and that's going to give me x is equal to 1.75. Now you can go ahead and check by plugging that back in. 8 times 1.75 is 14, plus 7 times negative 1 is negative 7. 14 plus negative 7 does give us an answer of 7. So our final answer for this system, written as an ordered pair, is 1.75 for x, comma, negative 1 for y. Go ahead and try this one on your own. In this case, 6 plus negative 6 is what eliminates. So we are adding these two equations together. 6 plus negative 6 is 0 y's. So 4x plus 3x is 7x. 32 plus 3 is 35. Solve getting x is equal to 5. Plugging that back in, we get y is equal to 2. So our point of intersection is at 5, 2. Next thing we're going to do is a quick word problem. So twice a number increased by 7 times a different number is 33. So we have twice the first number, so I'm going to say that's 2x, and then we've got increased, so plus, by 7 times a different number, so 7 times a second number, I'm going to call it y, and then we've got is 33. If the first number, which is x, is multiplied by a negative 2, so now we've got negative 2 times x, and then decreased, so subtracting 9 times the second number, which is y, our result is negative 39. So we've got our two equations. Now we're looking for what's the same. In this case, it's our x's. If I have a positive 2 and a negative 2, in order to eliminate that, I'm going to add these equations together. 2 plus negative 2 gives me no x's. 7 plus negative 9y gives me negative 2y. And 33 plus negative 39 gives me negative 6. In order to finish solving for y, I'm going to go ahead and divide by negative 2 on both sides, giving me y is equal to 3. Then I'm going to need to go ahead and plug that back in to find my second answer. So I'm going to take my first equation and say 2 times x plus 7 times 3 is equal to 33. When I do 3 times 7, I'm going to end up with an answer of 21. So I've got 2x plus 21 is equal to 33. Subtracting 21 from both sides is going to give me 2x is equal to 12. And finishing by dividing by 2 on both sides gives me x is equal to 6. So my final answer for the two numbers are 6 and 3. Go ahead and try this one on your own. So we set up our two equations based on our words. In this case, we've got opposites again, so we're going to add them to eliminate. We solve for y, that gives us negative 1, and plug it back in, solve for x, gives us 2. Now we're going to talk about what happens if we don't have something that match, because not every equation is going to start with matching pieces. So in this case, we've got 6x minus 2y is equal to 10, and 3x minus 7y is equal to 19. None of our variables match right now, but we can modify our equations to make them match. If you notice in this case, 6 and 3, those are multiples of each other. So if I took this whole second equation and multiplied it by 2, my first equation stays the same. 6x minus 2y is equal to 10. If I multiply the whole second equation by 2, I'm actually going to make it a negative 2. That gives me negative 6x. Negative 2 times negative 7 is a positive 14y. Negative 2 times negative 19 is positive 38. Now, why did I change it from a 2 to a negative 2? Personally, I like adding when I try to eliminate. So in order to make it an addition problem, I need my signs on my matching variables to be opposites. So I can now add all of this together. 6 plus negative 6 gives me 0 x's. Negative 2 plus 14 y's gives me 12 y's. And 10 plus 38 gives me 48. Continuing to solve, I'm going to divide by 12 on both sides, giving me y is equal to 4. When you plug back in, you should always plug into one of the original two equations. So even though we multiplied the second one by negative 2 as we solved, when we plug back in to find the second variable, we always want to make sure we use an original equation. So I'm going to say 6x minus 2 times 4 is going to give me 10. When I multiply, I'm going to get 6x minus 8 is equal to 10. Adding 8 to both sides is going to give me 18. So I've got 6x is equal to 18. And my final step of dividing by 6 is going to give me x is equal to 3. So I've got my answer of x is equal to 3 and y is equal to 4 for a final solution of 3, 4. Go ahead and try this one on your own. Multiplying that second equation by negative 3, we get negative 9x minus 6y is equal to a positive 12. Going through then, we can solve for y, and then plugging back in, we solve for x and get a final answer of 2, negative 5. Now what happens if neither of our variables match and they are not multiples of each other? So 4 can't multiply to 6 and 2 can't multiply to 3. What you have to do then is multiply both equations. So you get to pick x or you get to pick y. Personally, I'm going to pick y because the numbers are smaller. That's the only reason I decided to pick y as opposed to x. In this case, you're going to just want to multiply by opposites. So 2 and 3 are my numbers. I'm going to multiply the first equation by 3, and I'm going to multiply the second equation by -2. Again, I use the negative, so that's when I get my matching variables. They're opposites, and I can add the equations together. So the first equation ends up being 18x plus 6y is equal to 6. My second equation ends up as -8x minus 6y is equal to -16. When I add these two equations, I end up with 10x, 18 plus -8 is 10. 6 plus -16 is -10. I finish solving by dividing both of those by 10 and get an answer of x is equal to -1. Now, I need to plug it back in. Again, I'm going into one of the original equations, so I'm going to pick the top one. 6 times -1 plus 2 times y is equal to 2. When I do 6 times -1, that is going to give me an answer of -6 plus 2y is equal to 2. I'm going to next add 6 to both sides of my equation, giving me 2y is equal to 8. And I'm going to finish by dividing by 2 on both sides, resulting in an answer of y is equal to 4. So my final solution to the problem is x is -1 and y is 4. Go ahead and try this one on your own. In this case, I tried to make my first two match. So I multiplied the top one by 5 and the second one by -4, resulting in the two black equations. Finished solving for y, plugged it back in, got an answer for x. Last thing we're going to talk about with elimination is what happens when we have either no solutions or infinitely many solutions. So, if we're looking at these two equations, we don't have a matching variable, but I can see that 7 is a multiple of 14. So I'm going to multiply this whole original equation by -2. That results in -14 minus 6y is equal to -28. When I add these two equations together, 14 plus -14 is 0. 6 plus -6 is 0. So my whole left side of the equation equals 0. 28 plus -28 is also equal to 0. This should indicate to us that there are infinitely many solutions to this problem. So what does infinitely many solutions actually mean? It means anything that we plug into the first equation is also going to work for the second equation. So for example, in the first equation, if I plug in 2 and I do 7 times 2 plus 3 times y is equal to 14, I get 14 plus 3y is equal to 14. Subtracting 14, I get 3y is equal to 0, so y is equal to 0. So that means 2, 0 is a solution to my problem. If I plug 2, 0 into the second equation and I do 14 times 2 plus 6 times 0, I hope my answer is 28. 14 times 2 is 28 plus 0 is equal to 28. So any possible answer you can get for the first equation also works for the second equation. Again, that's because when we put it on the graph, those two lines would be the exact same lines. So when you get an answer that says 0 equals 0, that's going to be infinitely many solutions. If you ended up with an answer that says 0 equals 5, that's going to be no solutions. It is not possible for 0 to equal 5, so those two equations in that problem could never intersect. They are parallel. Go ahead and try this one on your own. When we multiply that second equation by 3, and then we're going to subtract the equations, we end up with 0 on the left side, -9 on the right side, and that gives us no solution. If you multiply the second equation by a -3, you still end up with 0 is equal to -9. You just did that by adding. Last thing that we are going to talk about in this video is how do we decide which of our three methods is the best? So the first method in section 4.1 we talked about graphing. In the second section 4.2 we talked about substitution. And then the first part of this lesson focused on elimination. So as you can see in this chart, there's some clear ways for how we can decide which one is best. Graphing, if we have something in y equals mx plus b format, where it's easy and quick for us to find that y-intercept, use the slope to find a second point, draw the lines, it's going to be okay to graph. The key thing with graphing is it shouldn't have to be a precise answer. If you're quickly tossing around the graph saying it's about this point of intersection and that's good enough, then go ahead and use graphing. This is probably the method that you will use least often to solve a system of equation. Substitution works well if one or both of the equations is solved for a variable. So if an equation says x equals 2y plus 7, it's super easy to plug in for x into the second equation. Or if it says y equals 4x plus 8, it's super easy to plug into y for the second equation. If either of the variables has a coefficient of 1, and you can easily solve to get one of these by itself, substitution is also an option in that. So if I had x plus 3y equals 8 and 4x minus 9y is equal to 10, I could easily subtract 3y and then plug x into the second equation because the coefficient on x is 1. So that's another way that we can use substitution. For elimination, matching coefficients, so if you had a 6x and a 6x, because then we can use subtracting to eliminate. Or opposite coefficients, if you have 6x and negative 6x, we can add to eliminate those. So if we've got those matching pieces, whether they're the exact same or opposites, we can quickly eliminate one of the variables. Or if an equation has a coefficient that's a multiple of the other, so 6x and 3x, easy to multiply that second equation by a factor of 2 or negative 2, and then use elimination from there. So this is a general rule for when it is the best to use each of these. Ultimately, you can use any one to solve any problem. Some of them just set up easier than others. So looking at this next problem, we've got 5x plus 8y is equal to negative 2, 3x minus 4y is equal to negative 10. Neither of them are in y equals mx plus b format, so graphing's off the table. Neither of them are solved for a variable or have a coefficient of 1, so substitution isn't really going to help us. So we're going to go to elimination then. If I look, my y's are set up nicely to eliminate because 4 is a factor of 8. So I can take this second equation and I'm going to multiply it by 2. So we've got 5x plus 8y is equal to negative 2. And my second equation then becomes 6x minus 8y is equal to negative 20. I'm going to add to eliminate. So I've got 5 plus 6, which is 11x, negative 2 plus negative 20, which is negative 22. I'm going to go ahead and divide by 11 on both sides, giving me an answer of x is equal to negative 2. When I plug that back in, I'm going to use the first equation, and I'm going to say 5 times negative 2 plus 8 times y is equal to negative 2. 5 times negative 2 is going to give me an answer of negative 10 plus 8y is equal to negative 2. I'm going to go ahead and add 10 to both sides of the equation. And when I do that, it says 8y is equal to 8. And the final step of dividing both by 8 is going to give me an answer of y is equal to 1 for a final solution of negative 2, 1. Go ahead, look at this problem, decide which method is the best, and then solve it on your own. In this case, substitution is going to work best. Y was already solved for, so I can plug in the place of y. When I do that, I get an answer for x, plug that back into the y equation, and I get a final answer of negative 2, 6. If you have questions about this or anything else from the lesson, please let me know when you get to class.